Hey everyone, we're going to take a look at exercise 57. Rewriting as a power of x. And the most important rules that you should remember for that are those two here right now. If you watch the theory video or read the theory yourself, you see that the root a can also be rewritten as a fractional exponent a to the power of a half. And this rule we know from first grade as well. If I have 1 over a to the power of p, that's the same as a to the power of negative p. And we can use both of those rules in conjunction with other rules sometimes as well, by the way, to rewrite some of those powers to powers of x. And they get more difficult the further we go. So let's take a look. X root x to the power of 3. And we can now do this two different ways actually. What some people would now be inclined to do is say, well, from the previous theory we know that root x to the power of 3 would be the same as root x squared times root x, which is the same as x root x, which is totally fine. And then you should use this rule here and rewrite root x to, in this case, x to the power of a half, because that's now something we know can be done. But what you can also now just do in one go, and that's maybe a bit quicker, is say, well, let's just cut out the middleman and immediately say, well, we know that a root then divides this thing up in two different, a root of a power can be calculated by just dividing the exponent by 2. We find this immediately, and I think that's a bit quicker. And then previously I said, well, we don't want fractions or root. Well, sometimes we want them. For example here, right as a power of x. And this is a bit quicker here. And this we can simplify into one thing, because remember, this is the same as x to the power of 1 times x to the power of 1.5. And when multiplying powers, we add up the exponents. So this is what happens, right? Believe it or not, this is the answer. X to the power of 2.5. This step here you don't have to write down, by the way, but that's what's happening. Let's see if we combine this with fractions. Yay. And let's first try to bring this thing into 1 power of x, which we can do, because root x is the same as x to the power of a half. So we get this. And this is not x to the power of 1. Please don't do that. Remember, this is a multiplication of powers. So we add the exponents, which is x to the power of 2.5. 2 plus a half is 2.5. Don't do 2 times a half is 1, right? Powers multiplied, add the exponents. And now we have to use this rule here. 1 over a power is the same as that power with a negative exponent. 1 over this power is the same as taking that power, but now not do to the power of 2.5, but minus 2.5. And this is your answer, because now it's rewritten as a power of x. The only thing I would change is that I would write it down on this line. It's a bit nicer. Right? Let's try another one. C. 1 over x squared root x to the power of 9. Okay? Again, first focus on the denominator. X to the power of 9, if I take the root of that, remember that's not x to the power of 3, that's x to the power of 4.5. I divide the number inside the root by 2. And this is a fractional thing, but again you will see that doesn't really matter for this kind of exercise. Multiplying those two powers gives me x to the power of 6.5. And now using this rule, I can rewrite this as x to the power of minus 6.5. Just take this thing but then a negative variant of that. Okay? Let's go back to an example without a fraction. And here you have two choices, I think. You can first do the power of products, or you can first simplify what's inside, and I maybe prefer the second way to do it. So I'm first going to try and bring this down to 1 power of x, because we now know that we can just divide the exponent by 2. So we get this, which it now is the same as this. Multiplying powers means adding up the exponents. And now, remember, this is a power of a power, so now I have to multiply the exponents. So I find 4 times 3 is 12, 3 times 12 is 1.5, so this is x to the power of 13.5. You could have also you can also do x squared times, x squared to the power of 3 is x to the power of 6, and then take root x to the power of 5 to the power of 3 is root x to the power of 15 is 7.5 times x to the power of 7.5 times x to the power of 6 is also x to the power of 13.5. That's the other way to do it. As long as you find this, you did something correct, I guess. Oof, and now e, and I think e can be very tricky. Let's take a look. We have this. Okay. Again, fractions inside of fractions, and then also letters, and then also powers, and also roots. This might frighten you. If I give you one tip, focus on those things separately first. This is a unit, this is a unit. Then take a look at it as being a fraction. So can we write this in such a way that it's simplified, that it's easier on the eye, and can I do that for this one as well? Let's start with the top. The top part, numerator, is just this. And that helps us because then I can rewrite it without it being a fraction. And that gets rid of a fraction in a fraction, which I prefer. So this is the same as taking the denominator, but then to the negative power. So this is the same as this, uses this rule. Over root of x to the power of 5, I can just divide the exponent by 2, so that's the same as this. And this is already a lot easier on the eye, but what you now should be able to do is, and that's a rule not here in the list, but it was a rule that we have taught you in first grade, that if you have this, let's see, how should they have given that rule? I think they've given that rule like this: a to the power of p over a to the power of q is the same as a to the power of p minus q. That meant if you had something like this, x to the power of 12 over x to the power of 2, that would be the same as x to the power of 12 minus 2, which is x to the power of 10. And this is the abstract rule. This is an example of the rule with p being 12 and q being 2. Here we can apply this rule because this is division with powers with the same base. So what we can do is, okay, we got x to the power of minus 2 over x to the power of 2.5. That's the same as x to the power of minus 2 minus 2.5 p minus q. And that gives me x to the power, believe it or not, of minus 4.5. And this is the final answer because I've rewritten it as a power of x. Okay? And I think we maybe need this rule for f as well, so I'll leave it there. X root x over x to the power of 5 root x to the power of 5. Yeah, okay, why not? Again, take a look at those units separately. The top is the same as x times x to the power of a half. Root x is the same as x to the power of a half. And the bottom is the same as x to the power of 5 times the root of a power means I divide that power by a half, so we have this. This, and I go down here, this I can simplify. Remember, x to the power of 1 times x to the power of a half is the same as x to the power of 1.5 over x to the power of 5 times x to the power of 2.5 is the same as x to the power of 7.5 at 5 and 2.5. And now I have to use this rule again, that it is the same as x to the power of 1.5 minus 7.5, which is x to the power of minus 6. The last two I think are very tricky at first glance, but if you've practiced this, you see this is just applying multiple rules in different stages of the exercise. And then you should be able to do it. Mind you, this is quite tricky though, as in the test won't be just 6 exercises of this, because I think that would be a bit mean to ask quite such a difficult exercise that often on the test. But this oftentimes does come back at the test, at, for example, an A and B exercise or only an A exercise. So do practice this well, please. Okay, good luck, and I'll see you soon.